My name is Daniel. In this video, I'm going to show you how to prove monotonically increasing of this function 1 plus 1 over n to the power of n. So we are going to use the binomial expansion to prove that. So basically, we want to show 1 plus 1 over n to the power of n larger than strictly 1 plus 1 over n minus 1 to the power of n minus 1. That's the previous term of this one. Okay. So let's expand the 1 plus 1 over n to the power n using binomial expansion. So the first term is 1. Okay. Actually, there's a cn0. Okay, cn0 is 1. Okay. And then the second term is cn1, n negative 1. Okay. And then the next term is cn2, n minus 2, all the way to cn n minus 1, n to the power of negative n minus 1, plus cn n minus n. Okay, that's the 1 plus 1 over n to the power of n. Then the right hand side here, okay, can be expanded similar way using the binomial expansion. 1 plus cn minus 1 times n minus 1 to the power of negative 1. Okay, and then the second time is cn minus 1 2 n minus 1 to the power of negative 2, and all the way to the last term cn minus 1 n minus 1 and n minus 1 to the power of negative n minus 1. So there are here from 1 2 all the way to n minus 1. So they are n minus 1 terms. Okay, and but this 1 plus 1 over n, there are n terms here. Okay, there are n terms here. So except the last term and the leading one, so these n minus 1 terms, okay, will be corresponding to this. So our goal is to show each of the term is larger than its corresponding term below. Okay, so I want to claim that cnk, the kth term, okay, to the power of n, m to the power of negative k, larger than cn minus 1k. Okay, so the index subscripts 1 goes from 1 to 3 all the way to n minus 1. Same thing here, 1 2 all the way to n minus 1. So k goes from 1 2 3 all the way to n minus 1. And then corresponding below here, the k term is c n minus 1k times n minus 1 to the power of negative k. Okay, negative k. So that is what we want to claim. If we can claim that, then obviously this term is larger than this term. Okay. So to do that, we try to expand the cnk, the combinatorial formula. So cnk is equal to n times n minus 1 all the way to n minus k plus 1 divided by k factorial. Okay, and then this n to the power of negative k, and we can move the n to the power of negative k to the denominator, so it becomes n to the power of k. Similarly, we can expand the cnk, cn minus 1k right here, and then similarly, this is equal to n minus 1, n minus 2 to n minus k divided by k factorial times n minus 1 to the power of negative k. And n minus 1 to the negative k can move to the denominator, so it becomes n minus 1 to the power of k. Okay, and notice that there are k terms. There's the first term, 1 2 all the way to k, and there are k power here, and there are k terms here, but k goes from 0 1 all the way to k minus 1, and there's a k in here, and you got a k factorial is the same. So the next step is I want to show that n divided by n of, if you expand n to the n terms, so each of the terms in the numerator will get 1n. Okay, and similarly here. So you're gonna prove that the term, each corresponding term will larger than each corresponding in here. Okay, so to do that, we just distribute the n to the power of k to each of the terms. So it becomes n divided by n, the first term, n minus 1 divided by n, all the way to n minus k plus 1 divided by n. Okay, so we have here we have the k, okay, k terms here. So in general, n minus m divided by n is one of the term, the m term. Okay, m term of this is equal it's actually m minus m divided by n. M goes from 0 all the way to k minus 1. Okay, and the other side, m minus 1, m minus 2, m minus k divided by m minus 1 to the power k, and we can do the similar expansion. We distribute m minus 1 to the power k to all the terms. So it becomes m minus 1 times m minus 1 times m minus 1 times k times. Okay, and each of the term in general, the m plus 1 term, okay, m plus 1 is corresponding to the m term here upstairs. Okay, so it's m plus 1 divided by m minus 1. So our goal is now to show this guy is actually larger than, strictly larger than this guy, and we're done. Okay, so this guy n minus 1, n minus m divided by n is equal to 1 minus m divided by n. Okay, and this guy, okay, is equal to n minus 1 minus n divided by n minus 1. So n minus 1, is 1 minus m divided by n minus 1. Okay, so now here compare these two terms. One is 1 minus m divided by n, the other is 1 minus m divided by n minus 1. And obviously this guy m divided by n is smaller than this guy, so 1 minus smaller numbers will be larger. So upstairs this one will be larger, so we show this guy is actually strictly larger than this guy, and therefore we prove that this original claim, this 1 plus 1 over n to the power of n larger than 1 plus 1 over n minus 1 to the power of n minus 1. So that's got approved. That is show that this is strictly increasing, so it's monotonically increasing function of this guy. As a matter of fact, this one, if n goes to infinity, this is e, natural log of base e, about 2.7. That's all I have to do. Have fun.